Welcome to today's Science Inquiry. I'm George Wolf, and today's inquiry uses an empty can, a hot plate, and a bucket of water. Now, I want to start off by being totally honest with you. The can's not truly empty. Nothing is really ever truly empty. And this can, if you'll notice very closely, has some steam coming out of it, which means that I have boiling water in here. Now, this is not one of these things I want you guys to try at home for a couple of reasons. First of all, you probably know that if there was not a hole in the top of this can could explode. And that's very dangerous. But this hole is allowing the steam to escape. Now let's get right to the whole challenge here. And here's what I want you to think about. I'm going to pick this can up, and I'm going to plunge it into this water. And I'm going to turn it upside down as I do that. You got 3 seconds to figure out what's going to happen. 3, 2, 1. Okay, let's take a look. All right, something clearly happened. Let's take it out. Ah, I love science. All right, look at that. Look at that. That can clearly doesn't resemble the can that I put in there. Something pretty nasty happened to it. Now, before you try to figure this one out, you may want to look up a particularly important term, and that term is atmospheric pressure. And after you look that term up, try and answer the question that goes along with this inquiry. Why did the can collapse? And would it have collapsed if I didn't turn it upside down? You know, a lot of you guys said that I had to turn that can over to make it crunch, and you were absolutely right. And the magic to that is this thing called atmospheric pressure. Did you know that the atmosphere, the air around you, as you sit here listening to me, is pushing on your body? Can you feel it? Well, probably not. But it's pushing on your body with a force of 14 pounds on every square inch. You don't feel it because you're used to it, but every square inch, 14 pounds, that's enormous pressure. Well, why did it cause the can to collapse? And why did I have to turn it over? Well, let's go to the board and let's talk about this. All right, you know I had you look up something called atmospheric pressure, and in the end, that's going to be the single most important point to this demonstration. But let's take a look at what we're talking about right here. Here's the can on the hot plate before anything happened. There's a hole in the top of the can, and there's water down at the bottom. The water isn't boiling, okay? Meanwhile, there are air molecules in there. But then I turn on the heat. Now, if we take a look at what happens here, the water starts to boil. We call that vaporize. We start to get pressure building up in there. Now, if I didn't have this open, this would be horrible because the can would explode, because the pressure would build up inside. But the steam is pushing up out of there, and it is coming out the top. Well, as the steam pushes up out of there and comes out the top, we get what is called a loss of pressure. Well, now I'm going to flip it over and put it in the water. Let's see what happens. And you guys who said I had to turn this upside down nailed this. When I put it in the water, what happens? Well, let's think about it. Is it boiling anymore? No. Is it off the heat? Yeah. Is it cooling down? You bet. And what happens to steam when you cool it down? It turns back into water. So literally all that water vapor in the atmosphere that I had on that last picture shrinks down in. Well, what does it want to do? It wants to suck air in that hole, but it's upside down. So it can suck air in that hole. We have what is called a vacuum. And the atmosphere pushes on that can with that atmospheric pressure of 14 pounds per square inch, and squish, the can is destroyed. Okay, let's summarize. Point number 1. Atmospheric pressure at sea level is pushing on every square inch of your body with a force of 14 pounds. Number 2, boiling water causes the water to expand, which increases pressure. Point number 3, cooling water causes the water to contract, which decreases pressure. Point number 4, when pressure is greater than atmospheric pressure inside something, it can explode. When pressure is less than atmospheric pressure inside something, it will collapse. Thus, our can collapsed. Hey, I'm George Wolf, and I want you to remember to discuss today's science inquiry with your class and your teacher. And I'm going to give you more of these next time. But remember, you're not going to get any answers until you ask those great questions.